Hi guys. So as promised, what we're going to do today is we're going to move into the new topic, chapter 11. So what are we going to cover as part of chapter 11? So as part of chapter 11, we will cover three major areas. What are the three major areas that we will cover? We will cover number one, asset replacement cycle. Number two, we will cover lease or buy decisions. And finally, number three, we will cover capital rationing type question. Okay, let me share my screen first. Okay, so from my notes, don't worry, I'm going to zoom in a bit. All right, so from my notes here, you can see that the first decision that we're going to do is asset replacement decision. Number two, lease or buy, and three, capital rationing. So what I've done here is I've given the details on all or each individual area, i.e. capital asset replacement cycle, lease or buy, and also capital rationing. And I've also included my method, the format, and the structure that I use. And at the same time, I've also given you some of the reasons of you to perform this calculation. So number one, asset asset replacement cycle. So let me scroll in. Okay, so what is asset replacement cycle all about? What are you trying to achieve when we are learning asset replacement cycle? So when you are learning an asset replacement cycle, basically what we do is we are trying to compare whether or not we continue holding the asset or we replace the asset. Okay, why do we do this calculation? What's the reason for us to do this calculation? Is because sometimes when you have an asset in your company, the point of holding the asset is because the asset can help you to generate cash flow to the company, because the higher the productivity of the company's asset, the higher the sales that you can make, so you'll be able to sell more. That's number one. Number two, when your asset is kept in your company for a long period, what happens is that sometimes you hold the asset for just way too long that you are unable to make good use of the asset. Example, the asset does not remain productive anymore. So you can see that over time, the number of units of your asset that you produce will be much lesser. So if I give you a more realistic example, let's say you guys, okay, if you have enough rest, okay, and I ask you to do questions, you will do it in a more active, proactive manner, rather than if you didn't sleep whole night and then I keep forcing you to do a question, you would probably feel like you don't have the energy to do so. So similarly, for an asset, sometimes you use it just way too much without any maintenance, without any upkeep, in such a way where this asset now will start to generate or will start to not be as productive as expected. Okay, so what you are doing in an asset replacement cycle, okay, or you can also call it as an asset replacement decision, what you are doing is you are trying to find the best way for you to be able to identify whether or not to hold the asset for a longer period or whether to sell and replace this asset. Okay, so how do you do it, and what kind of calculation do you perform? Okay, now when you talk about asset replacement decision, you must also understand that it is a form of a discounted cash flow technique. All right, where in order for you to decide whether or not to replace the asset, you will calculate the equivalent annual cost method. All right, so you will use the equivalent annual cost and you will compare which is the higher cost, whether it's the cost to replace is higher or not. If the cost to replace an asset is higher, you will choose to keep it until the replacement cost is much lesser. Okay, now the next one. So what do you need to do to get the EAC, or how do you perform the calculation? Okay, so as you know, maybe I need to annotate a little bit. Okay, as you know, when you want to calculate the asset replacement cycle, the format or the formula to calculate it is very straightforward. It is NPV over annuity factor. That's all. You get your EAC. Okay. So what you need to do here is you need to be able to calculate the NPV, but please bear in mind that the NPV that you are calculating here is actually the NPV that is only relevant to the machine cost only. Okay, so this is the NPV that is relevant to the machine. Now, besides that, what you also need to understand is, so how do you then make a decision when it comes to asset replacement cycle? So the decision that you make when it comes to asset replacement cycle is that you will compare between few different machineries to identify whether or which machinery is the one that will cost you higher. So if it costs me higher, okay, for me to hold or sell the machinery, then I would choose the machine which would cost lesser. Or what is normally done by the examiner, that means this is the common method for examiner to test you. He will give you one machine, he will give you few different EAC. Example, EAC in year 3, EAC in year 2, EAC in year 4. So between the 3 EACs, you need to choose which one is the lowest EAC. That's your objective. Okay. Now, the examiner can also ask us to calculate the equivalent annual benefit. So when it comes to equivalent annual benefit, you must remember that you must take the highest equivalent annual benefit. So how do you perform this calculation? What do you do to perform this calculation? Like I told you, equivalent annual cost or benefit divided by the annuity factor of the project. Okay, so number one, let's say if I want to put it in steps, number one, use the NPV format to calculate NPV. So basically you are just calculating NPV. Number two, you must identify what is the annuity factor. And number three, you need to identify what is the EAC or EAB. So 3 steps. So this one, we already learned it when we calculated our NPV in chapter 7 all the way until chapter 10. And this you can just get from your formula sheet. Or you can use the calculator to do the way I do it, or you can also use the Excel to do it the way I do it. Now, so without further ado, what we can do is we can do one question, one example for us to be able to enhance our knowledge here. I'm going to share my screen where I have all the... Yes, okay, so guys, this is from the technical article. Okay, so what do I have to do? Okay, here. calculate the optimal replacement cycle for the machine. Okay, when he asks you to calculate optimal replacement cycle, he's asking you to decide when do you need to replace your machine, or how frequently you need to replace your machine. So in order for you to do that, you need to calculate the EAC. Now, example 1. A machine has a cost of $3,500. So this is my investment cost of the machine. The annual maintenance cost of the machine are forecast to be $900 in the first year, $1,000 in the second year, and $1,200 in the third year of ownership. The residual value of the machine is expected to be $2,100 after 2 years and $1,600 after 3 years. So guys, the examiner has given you two different scrap values. So how do you perform this calculation? It means that you need to perform the EAC for year 2 and year 3. Okay, the cost of capital is 11%. So guys, I'm going to switch my screen now. I want you to be careful, because when you do a question like this, normally students have a common mistake that they make. Okay, so what are the common mistakes that we want to try to avoid? Okay, I'll just scroll to a new page here. Okay, so okay, so the first one, okay, example number 1. Remember, he gave you 2 different years for your EAC. So you need to calculate the EAC for year 2 and also for year 3. So how do I proceed with that? So year 0, 1, 2, okay, running costs, initial investment, scrap value, net cash flow, DCF at, okay, how many percent? 11%. PV and NPV. So my machine running cost will be 900 and 1000. So guys, please remember this is in negative because it's a cost to your company. Your initial investment is 3,500. Do you have a scrap value? Yes, the scrap value in year 2 is expected to be 2,100. This is the only positive cash flow. So my net cash flow for year 0 is 3,500, 900 and 1,000, sorry, positive 1,100. So here 1.000. Okay guys, I think this is 0.901. Let me double check. All right, 0.812. So to calculate my present value, 3,500 900 810.9. Okay, I'm just going to round it up to become 811, okay, to make it easier. And then 893. So what will my NPV be? Okay. $3,418 negative. Okay, guys. Now I just want to remind you that this is already a cost, right? This is already a cost. Hence, that is why when I do my EAC, remember it is NPV over annuity factor. So what I will do, I will not put the negative sign. The reason why I did not put the negative sign is because here I've already indicated that this is a cost. So because I've already indicated that this one is a cost, so I don't have to put the negative sign. Because students always ask me, Miss, why you didn't put the negative sign? Because I already mentioned that it is a cost. Now, annuity factor 11%, 2 years. One point one seven, 1.713. 3418 over the answer. So the cost of running the machine for 2 years will be 1.995. Now guys, this is only the first part where you calculate your EAC for 2 years. So this is EAC for 2 years. Now, your EAC for 3 years. Okay, this is where it gets tedious. What you have to do is you have to recalculate this whole working, and you cannot be lazy, because when you are lazy, you will tend to make a careless mistake. No matter how smart of a student are you. Okay, there is that careless mistake that you can make. So I would recommend you to not try to do a shortcut. Okay, so scrap value. Net cash flow, discount factor, PV and PV. Now, so here my running cost is 900. It was 1,200. I cannot remember what was it in year 3. Oh, sorry, 1,000 and 1,200. Year 2 is 1,000, 1,200. My initial cost 3,500. Now my scrap value in year 3 would be 1,600. Okay, so that is the only positive figure. Net cash flow 3,500, 900, 1,400, 1.000, 0.901, 0.812 is 0.756. 0.731. Okay, so when I calculate the present value, 3,500, guys, actually I can just copy and paste the year 2. Okay, 811. This will be 812. Okay, this will be 292. So when you total up everything, my NPV will be negative 4831, negative 4831. Okay, so my EAC is equals to 4831 divided by, guys, so remember, no need to put the negative value. The reason why you don't have to put the negative value is because you don't actually need to show that it's a cost. The reason why is because you already called it a cost, so that's the reason why. Now, what will be my annuity factor? 2.444. Okay, so what will be my cost? So the cost is 1.1977. So guys, when you want to compare between the two machineries, I need you to compare 1995 and 1977, and I need you to let me know which one is the lowest EAC. Okay, so you compare. So EAC, wait, okay, so the cost that is higher clearly is this. So we will choose this because the higher cost means when you want to hold the asset, okay, or you want to replace the asset in that year, it's expensive. So you want to replace it at a cheaper price. When you want to replace it at a cheaper price, it would be replacing the machine every 3 years. So your conclusion will be the asset can be replaced every 3 years, not can, should be. 3 years as the cost is cheaper. Okay, guys, I just want to bring your attention to one part here. So when you calculate the EAC, you get 1997. What is this 1997? Okay, so the 1997 is actually the cost that you incur every year for this project. Okay, for this project or for this asset when you hold it for 3 years. Okay, so for year 3, for the 3 years asset replacement cycle, that means every year, on average, the cost that you incur is 1977. But if you hold the asset for only 2 years, every year, the cost that you incur is 1995. All right, so that's why, guys, maybe I show it to you this way. So if I take EAC, multiply by annuity factor, is equals to NPV. This is my discount factor. This is my cash flow. That means this is the cash flow that you incur every year, okay, that will give you this NPV. All right, so this is actually calculating how much cash flow do you incur on a yearly basis, right? Now let's move to the second part of the question, which is equivalent annual benefit. So for equivalent annual benefit, you can see here, he asks you to calculate which project the company should accept. Now, for this project, you have two mutually exclusive projects. Okay, this example, you got two mutually exclusive projects. So what does it mean by mutually exclusive? If you take on one project, you cannot take on the other one because it is too pricey. Because one project will affect the other. Sorry, I don't know what I was thinking. Okay, now, so if you take project A, you cannot take project B. If you take project B, you cannot take project A. Okay, because one project will affect the other project. Now, project A, the NPV is 47 million. It will last you for 3 years. Project B, the NPV is 58 million. It will last you for 4 years. It is anticipated that if either project is chosen, it will be possible to repeat it in the foreseeable future. The cost of capital is 13% per year. So guys, first thing that I want you to note, the NPV in this question is positive. Oops. Because the NPV is positive, that is why it is an equivalent annual benefit, because positive NPV means cash inflow. Negative NPV means cash outflow. So the fact that you are doing the EAB, it means that this is the profit that your project will generate. Okay, now what do I do? Okay, to calculate EAB, the concept is similar. What you need to do is you just take your NPV over annuity factor. Now, the NPV that was given to you for project A is 47. This project will last for 3 years. So calculate 13% 3 years. 1.13, the power of negative 3, 1 over answer divided by 0.13. So 2.361. So what is the benefit of project A? So I'll just write EAB for A here. 19.91. All right. So the next one, EAB for project B. Your NPV is 58. The project will last for 4 years. So $2.974. So what is your EAB? 19.50. Okay, so guys, between project A and project B, which one will you choose? Okay, because this is EAB, whenever you choose a benefit, you always choose the highest benefit. Now, between EAB and EAB of A and EAB of B, which one is higher? 19.90. So you will choose project A. Okay, so this is as simple as asset replacement cycle gets. Okay, of course, you have few other questions that you can try when it comes to asset replacement cycle. We will do it together. Okay, in our tutorial session. Okay, I will move to list or buy first before I do the tutorial questions. Okay, so I will see you guys in the next video for list or buy decision.